Hi friends, I'm Yugen. Welcome to my YouTube channel Interesting Quantum. In this video, we are going to see how we can extract the information from the wave function, or we can say what the wave function does give us. So consider this example. Wave function psi is equal to capital A into e raised to minus L mod x into e raised to minus I omega t. So in this case, we can separate the space part and time part, and A is a normalization constant. So the complex conjugate of psi can be obtained by replacing minus I with plus I. So this is the psi star, that is complex conjugate. We know the condition for normalization is integration psi star psi dx is equal to 1. So substituting values, we can get integration minus infinity to plus infinity mod square of a e raised to minus twice L mod x, because psi star into psi e raised to minus Lx into e raised to minus Lx, so it becomes e raised to minus 2Lx, and the time part vanishes because one is plus and one is minus I omega t, so e raised to 0 is equal to 1. This is even function because if I can if I substitute minus x in place of x, due to mod x the sign is not changing, so this is even function. So I can use this rule 2 into integration 0 to infinity f of x instead of integration minus infinity to infinity f of x. So in next step we calculate the integration. So integration is e raised to minus 2lx divided by minus 2l. So in this case we do not need to put mod because all values from 0 to infinity are positive, so we can neglect the mod, and our limit is 0 to infinity. So by substituting the values we can get this as e raised to minus infinity is equal to 0. We can get in bracket 0 upon minus 2l, that is 0, minus e raised to minus 2l into 0 divided by minus 2l. So e raised to minus 2l into 0, so e raised to 0 is 1, and hence the solution is 2a square 1 upon 2l, or further we can write mod square a into 1 upon l. So this gives a is equal to root l. Now let us calculate the expectation value of x. So consider again the formula. Expectation value of x is equal to integration psi star x psi dx from minus infinity to plus infinity. So we can rearrange all things. We can take a square outside of the integration as it is constant. Again time part is vanishes because of minus I omega t and plus I omega t. So remaining part is integration minus infinity to infinity e raised to minus L mod x into x into e raised to minus L mod x. Now in this case, if I substitute minus x instead of x, the exponential term will not change, but the x between two exponential functions will change its sign. So this is odd function. So integration of odd function is 0, and that's why expectation value of x is 0. So what does this mean? Why the expectation value of x is 0? So this means the maximum probability of getting particle at position is 0, that is it is at origin, it is at the mean position. So if we are observing number of observations, so for maximum values you can get the position of particle at the center, that is at 0 position. Now we have calculated that a is equal to root L. By substituting this value into psi, we can get psi is equal to root L e raised to minus L mod x into e raised to minus I omega t, and psi star becomes root L e raised to minus L mod x into e raised to plus I omega t. So psi contains e raised to minus I omega t, and psi star includes e raised to plus I omega t. So now we calculate expectation value of x square. We have integration psi star x square psi dx. So in psi and psi star there is a, take a square outside, and the value of a square is L, so I have written it here directly. So now calculating, in this case also time part vanishes, and e raised to minus Lx and e raised to minus Lx becomes e raised to minus 2 Lx x square dx. So in next step, as this is even function, we can write this as 2 into integration 0 to infinity. So now calculating the integration, we have that is x square into e raised to minus 2 Lx upon minus 2L minus 2x dot e raised to minus 2Lx upon minus 2L bracket square plus 2 into e raised to minus 2Lx divided by minus 2L cube, and the limit is from 0 to infinity. So this integration I have solved under the rule integration of uv dx is equal to u into integration v minus u dash, that is derivative of u, integration of v plus u double dash, that is double derivative of u into triple integration of v, and so on. So by solving and putting the limits, we can get this value as 2 into 1 upon 8 L cube, and further solving we can get the expectation value of x square is 1 upon 2 L square. So in this case, the expectation value of x square is not 0. This means there is some spread. What our expectation value of x told us, that the maximum probability is located at x. But if our expectation value of x square is also 0, then it will tell us that all information is located at point 0. But this is not true because our value is non-zero. So this means there is some spread. So now we will see the momentum P, and it is given in operator term as IH cross dabba by x, or we can say IH upon 2 pi dabba by x. We can get expectation value of P is equal to minus infinity to plus infinity psi star. This is operator of P minus IH by 2 pi dabba by x into psi dx. We can take the constants outside the integration. So minus IHL by 2 pi are constant which is taken outside. In this case also time part is vanishing because d by dx do not operate on time part, it operates on only position, that is e raised to minus L mod x. So we have e raised to minus Lx in integration into derivative of e raised to minus Lx. So we have to first calculate the derivative of e raised to minus Lx, and then we have to multiply it, and then again we will integrate it. So derivative of this is minus L into e raised to minus Lx. So now multiplying and taking minus L outside of the bracket, we can get IHL square by 2 pi integration e raised to minus 2 Lx dx from minus infinity to plus infinity. Now again this is even function, and calculating integration we can get the value 1 upon L. So putting this value we can get IHL by 2 pi. This is the expectation value of momentum. Now we will see the energy. Expectation value of the energy is given by integration psi star energy into psi. IH by 2 pi d by dt is energy operator. We have to solve the integration, but before solving integration, in this case our derivative of psi is with respect to time, so we cannot neglect time here, but e raised to lx is the constant of the derivation, so we can take outside the derivation, and all the constants ih by 2 pi we can take outside the integration, so we can get lih by 2 pi integration e raised to minus 2lx, as it is constant of derivation because it is with respect to time, e raised to plus I omega t into derivative of e raised to minus I omega t with respect to time. So its derivative can be calculated easily, minus I omega into e raised to minus I omega t. So substituting this into integration we can solve further, and now we have taken I omega minus I omega outside the bracket, so I into minus I is plus 1, and in this case now again time part is vanished and only part remained in integration is e raised to minus 2lx dx. So solving this integration we can get 1 upon L, and substituting this value we have energy is equal to h omega by 2 pi, and this is the general formula of energy in quantum mechanics as well as in classical mechanics. Also we have used this formula for many times. So enough for this video. Thank you for watching. I hope you liked this video. Like, share, comment and subscribe this video if you have not subscribed yet. And don't forget to press the bell icon so that you can get further notification of next videos. Thank you.